In this video I'm going to find out two things. One, how long does it take to charge an iPhone 11 from completely dead battery, flat battery, to 100%. I'm going to determine this very simply with a super low-tech, high-tech stopwatch. My second question is, what is the charging wattage that this charging cube provides for charging this phone? There are different claims everywhere, so I'm going to measure it myself. I'm going to explain what this setup is for this wattage. Now, wattage cannot be measured directly, but amperage can. That's electric current. When voltage, 120 volts nominally, could be 119 or 118 for the voltage drop in the line. I'm going to measure that one as well. When voltage gets multiplied with amperage, you get wattage. So that's how I'm going to determine the wattage of this charging cube. The setup here for measuring current and determining wattages: electricity flows from the outlet through this 10-foot extension cord through that white contraption, which is terminated this way, so I can plug an alligator clip on one end. Electrons will flow through the red wire into the instrument that is set to measure in amps. Watch the decimal dot right there in AC, alternating current. So once I plug it in, charging will begin. Electrons will flow through the black wire as well, and through the alligator clip go to the charging cube. The phone will charge. The circuit is complete by this other wire, the red one here, that's just hooked around the prong of this charging cube and completes the circuit that way. So once I plug this one in, watch out the current drawn by the phone. It's set in amps, so watch the decimal dot there, so that's 0.04 something amps, whatever it is. And there should be an indication here of charge flowing into the phone. Oh, there is some sign of life on the phone now. I'll give it an hour and we'll check it back later, see how it goes. It's been 56 minutes into it and the battery level is at 32% at the moment. Still charging proceeds at this level of amperage, so that's 0.047, 48, 49, something like that. Sometimes it's there, sometimes it jumps to 50. So if I work with that number 0.05 and take it at 120 volts, then it's 6 watts. If it's down to 118 volts, then it's 5.9 watts, or this number here can be edited to 0.47 to match it with the display, and so 5.5 watts, so something like that. So that would be a range at the moment, and it looks like it's gonna continue at this pace, and I'll be done charging, I don't know, so that's a third of the battery in 1 hour. So give it 2 more hours, that's just an estimate. So far I'm doing between 5.5 to 6 watts. An hour and a half-ish into it, still ticking. The battery level is at almost 50%, so I guess it'll be done in 3 hours. The charge level is slightly down, so even fewer watts are being pulled, say 5 watts, whatever, 4.5, so the charging rate is slowing down a little bit, or the battery is being charged less aggressively, even though 6 watts is not aggressive by any stretch of imagination. Let's check out how this thing is going. 3.5 hours into it, when the screen is off, it's drawing 0.016 amps, which equals to a miserable 1.9 watts with this travel charger or whatever this thing is. And right now the battery is at 89%, So I don't know, another hour to go at this pace, some kind of trickle charge, whatever this is. Well, 4.5 hours into it, it's still taking on some charge, about that much. Yeah, if I put that in the calculator, it equals 0.72 watts, say 3/4 of a watt, and it's still not fully charged. It's at 96%. Brutal. A brutal 5 hours into it. I'm still doing the same amperage, so 3/4 or so of a watt. Oh, even less than that now. Maybe not, definitely less. And I'm at 98% charge, but that's not enough. And we have a finish, ladies and gentlemen. Took 5 hours and 15 minutes. Sorry, I forgot to stop it. And just changed to 100% there. When the screen is on, it's pulling more amps than without the screen, so there. It's trickle charges that number. Sometimes, yeah, it's, if I enter the 3, it's 1/3 of a watt if there is no voltage drop in the line. So that's exactly how long it took. It's been miserable. And finally, I've got 3 things to mention just to finish off the video. First, temperature affects the rate of battery charge. Right now the temperature is cold. This side is Celsius and this side is Fahrenheit. Suit yourself, it's coldish. Okay, not extremely, but whatever. So that affects it. Secondly, voltage. Voltage affects wattage. Instead of 120 volts, we have 118.125, whatever. It kind of fluctuates as voltage usually does. So make of it what you will. So that's the second factor right now. It's plugged in with the same instrument, same alligator clips, just set to voltage. And it's plugged in like so to the end of this white extension cable. So the line length of the setup is approximately the same. Third factor is, besides the temperature and voltage, is the instrument itself, the number of connections where contact arcing might happen, and that might affect the charging time. So I'm going to repeat everything without the instrument, just timing it from 0% to 100%. See if without the inherent loss of current and issues with this complicated setup, if I just plug everything into the wall directly, let's see if it's any faster than 5 hours and 15 minutes. So to eliminate some of those variables, I'm going to repeat the charging from dead flat. It's plugged in, but it's not powered on. I'm going to turn it on here. There, it's turned on now. There, started charging. And see how long it takes without any of the instrumentation plugged in or being in the way, and this is at room temperature. Let's check out the progress here. 63% reached in an hour 45 minutes. It is substantially faster, just at room temperature, plugged into the same charging cube. 3 hours 22 minutes into it. Let's see how we're doing. 99%. 3 hours 23 minutes into it. Let's see how we're doing. 100%. It just turned to 100. Okay, a lot faster